So to go along with our scientific notation unit, we are looking at all four of the major operations. This video focuses in on adding scientific notation numbers. So if we were to go back to second grade when we were learning how to add and subtract, the big thing that we have to worry about when you're adding numbers is all about that place value. So if I needed to add the number 300 or 3,000, let's say 3,275, and I want to add that to the number 203, we were taught that we could take these two numbers and we can line them up based on place value. You have the ones place, you have the tens place, hundreds place, and then this last number, of course, has the thousands place. So we have to make sure that they're all lined up properly down here. So 5 and 3 in the ones place gives us that 8, 7 plus 0. So we're really adding 70 plus nothing in the tens place. That's how we get the 7 for 70. And then 400 and 3,000. You know, if we were to expand it out, 3,000, we have the 200, we have the 70, we have the 5. The bottom number is the 200. We have nothing in the tens and 3 in the ones, and we could add appropriately. Hopefully, by this point in the video, you've probably skipped forward, which is fine. This is the same thing that has to happen in scientific notation, but it's a lot more like secretive almost. So if I have a number like 2.3 times 10 to the 5th, and I'm adding that with a number like 1.2 times 10 to the 3rd, place value is still a major component. We cannot just add 1.2 and 2.3 because they're not even close to the same place value. If I were to take both of these numbers out of scientific notation, so bring this power of 10 back to 0, this number right here becomes 2, 3, 1, 2, 3, 4 zeros, 230,000. I grabbed that decimal point and I moved it 5 times to the right. This number over here, I would grab the decimal and move it 3 times. It's just 1,200. That's it. So if I were to add both those numbers up, I have the 230,000. I add it with the 1,200. We can see that 2.3 plus 1.2 is not what we'd actually get. We would need 2.312 times 10 to the 5th. And that's all based on place value. So when we are looking at adding scientific notation, the first thing we have to do before we can add our scientific notation is the powers must be equal. They have to be equal. Once they're equal, then everything is lined up appropriately for their place value. So if they're not equal, we're going to make them equal. Once you have equal powers, so with equal powers, we're just going to add the numbers. Remember that scientific notation, you have the number, and then you have the power. Very different. This is the number, these are the powers. Number and power. The last thing we're going to check is to check that the answer is in scientific notation. So let's practice a few. So let's start with a pretty basic one. 5.5 times 10 to the 5th. And I'm going to add that with 3.2 times 10 to the 5th. So step number 1, step number 2, step number 3. All right. Step number 1, equal powers. Yes. Step number 2, we're going to add the numbers. So 5.5 plus 3.2. So 2 and 5 makes 7. 3 and 5 makes 8. So I've added the numbers. Oh, I knew there was something I left over here. So we add the numbers. You keep the power. Apologize for that. So after you add the numbers, you're going to keep the power that you have decided on. So 10 to the 5th, this remains 10 to the 5th. So there's step number 2. Now we're going to check to make sure it's in scientific notation. I have 1 digit left of my decimal point. So this is indeed our answer. If we had converted out, we would have 5, 5, 1, 2, 3, 4. This one we'd have 3, 2, 1, 2, 3, 4. We're basically adding 550,000 with 320,000. We get 870,000. 1, 2, 3, 4, 5 movements of our decimal point. And that's why it is 8.75 times 10 to the 5th. If they're not the same power, say we've got 2.3 times 10 to the 6th, and I'm going to add that with 1.5 times 10 to the 4th. Let's make that 10 to the 5th instead. I'm going to make one of these scientific notation numbers be in the same power. I can choose to drop this to the 5th power, or I can choose to bring this up to the 6th power. It is always a better choice to increase the power. Saves you a little bit of effort. So our power of 10 is larger, so I'm going to make this number be smaller. So 1 unit up, 1 jump smaller. So my 1.5 becomes 0.15 times 10 to the 6th. But since they're in the same power now, I'm allowed to add them together. This 5 adds with this 0. 5 plus 0 is 5. 1 plus 3 is 3. No, it's not, because Carlisle's an idiot. 1 plus 3 is 4. And then 0 plus 2 is 2. We keep the power, and now we check for scientific notation, which it is. All right, last example, I'm going to look at some negative powers. How about 5.39 times 10 to the negative 4th, and I'm going to add that with 6.27 times 10 to the negative 3rd. Step number 1, equal powers. We don't have them, so we're going to make them equal powers. So this is either going to become 10 to the negative 3rd, or this is going to become 10 to the negative 4th. This is the better option because our power is growing larger. So this number has to grow, well, has to shrink smaller. 1 jump. So I now have 0.53. Okay, that was weird. I don't know why that just happened, but here we are. Oh. Okay, well, I'm just going to put that over there. So we have 0.539. This number 627 times 10 to the negative third. We're going to add our two numbers together. 6.27, whoops, 6.27 plus 0.539 gives us 6.809 times 10 to the negative third. We're going to check to make sure it's in scientific notation. We have the 1 digit left of our decimal, so we're good there. But I want to round it to just 2 decimal places. So this 9 will round the 0 up, and we get 6.81 times 10 to the negative third. And that's it. If you choose to drop the power, I'll do just like a real quick demo like this. So if we were to drop this power to 10 to the fourth, that would cause this number to grow 1 decimal place larger. We get 32 times 10 to the fourth. But that's not scientific notation. We will grab that decimal, we move it back, and you notice that the power that we ended with, was the larger power to begin with. So that's why it's always better to use the bigger power. It saves you that one little bit of simplification at the end. And that's it.